Good morning, good afternoon, and good evening, depending on where in the world you're joining us from. Welcome to our GenAI Demo Day, brought to you by our headlining sponsor, Snowflake, and made possible by our sponsors, Zerv, Google Cloud, Precisely, Zenlytic, Fivetran, and Dataiku. I'm Brian Myung, co-founder and president of Data Science Connect, the world's largest data and AI community. Today, we're excited to welcome hundreds of attendees from all over the world for an exclusive virtual event showcasing the most innovative GenAI solutions through concise 10-minute demos. At DSC, we value your time and have designed this event to provide impactful demos without any unnecessary fluff. Quickly identify solutions that meet your business needs and connect directly with the top leaders of pioneering GenAI companies. We're honored to hear from a distinguished group of experts today from some of the leading solutions in AI. James Cha-Earley, Senior Developer Advocate at Snowflake, Greg Michelson, Co-founder and Chief Product Officer at Zerv, Holt Skinner, Developer Advocate of Cloud AI at Google Cloud, Nohyun, Senior Director of Product Management at Precisely, Ryan Jensen, CEO and co-founder of Zenlytic, Brad Moore, Senior Sales Engineer Enterprise at Fivetran, and Valentina Pena-Vivas, Senior Data Scientist at Dataiku. Before we begin, a few housekeeping items. To make this feel a little more in person, we suggest you add a photo to your profile and include your bio, LinkedIn profile, and other information you want your fellow attendees to see. Next, please take advantage of the Q&A and chat features throughout the webinar. Presenters may address your questions during their allotted 10-minute time slot, or they may respond directly in the Q&A and chat sections on the right-hand side of the screen. If you're wondering where your organization stands compared to others on your AI journey, check out the poll questions in the right sidebar. And finally, if you'd like to learn more about any of the solutions you see today or book a full demo, check out the calls to action below throughout the webinar from our sponsors. Now, without further ado, I'm excited to kick off Demo Day and welcome our first speaker to the stage, James Cha-Earley from Snowflake. Welcome, James.
Hello. Thanks, Brian. Thanks, everyone, for being here. Go ahead and share my screen. And off we go on our little magical journey. So today I'm going to tell you about Snowflake Cortex Agents. It's a powerful platform where you can build agents on top of Snowflake's infrastructure, as well as the resources and technology that Snowflake provides. Little safe haven text there for all of y'all. And let's go ahead and dive into the meat of our conversation. So as we live in this day and age of data, it's becoming more and more important that we look forward and really think about how we want to connect our data to the technologies that are coming up today. And Snowflake is expanding its AI capabilities with public preview of Cortex agents to kind of bring everything together. The big thing with Cortex agents is to be able to bring in information as well as insights from unstructured data as well as structured data, providing enterprises a way for your workforce to be able to connect to the data and get information that folks can use and make their lives a lot better at the end of the day, more getting their hands on the data quicker and more organized and directly, instead of feeding through and trying to find which page within the documentation they can find a very specific use case or quote or instruction to be able to make things happen. They can just ask a question to Cortex agents to make it all happen. So with Cortex agents, the big key pieces that it is utilizing is Cortex Analyst, as well as Cortex Search Service as its tools. It enables governed retrieval across structured and unstructured data utilizing those tools. And to kind of laid out more visually, we have those two structures. Analyst is utilized for structured data using semantic models, so that way you can find the information you need. And well as Cortex Search Service is essentially a simplified or a handy tool to make a radical implementation for yourself, so that way you can get up and running very quickly. So from a customer's perspective, AI agents can enhance business productivity by handling complex multi-step operation in minutes. All of us are familiar with the potential this technology brings to enterprises. But to do so, they need to access organizations' often sizable structured and unstructured data to be effective and reliable. So, in other words, for AI agents to work at scale, they need a seamless connection between enterprise data and LLMs while ensuring security and governance. They must follow data policies, access multiple data sources efficiently, and retrieve information accurately to deliver the meaningful outcomes. Which is why accuracy, trust and security, and governed access are the front and center of Cortex agents within Snowflake. So let's take a step back to see how this all kind of comes together. I gave you an idea of bits and pieces, but let's take another step into it. So at the core is governed data. Within Snowflake, secure perimeter. This includes both structured and SQL tables, as well as unstructured stored in stage. You can use granular RBAC to manage access across the data itself. Next is data processing. For structured data, Snowflake's state-of-the-art SQL engine that can provide scalable performance. On the unstructured data, you could perform pre-processing so that way the state of the data is ready to be consumed. For example, you may want to translate text or summarize documents, and AI Cortex provides access to LLMs in a simple function manner to make all these transformations ready for you. Next is the retrieval engine that consists of Cortex Analyst and Cortex Search, which are tools utilized by the agent to retrieve information. Cortex Search extracts insights from unstructured sources, while Cortex Analyst generates SQL to process structured data. Analyst has an out-of-the-box accuracy of 90%. You can create your own search service and analyst services to be customized for your data. So plainly, Cortex agents orchestrates tasks to use these tools and reflect the results in an improvised response. As part of planning, they explore options, split into smaller tasks, and route across the tools. At every intermediate step, they reflect on the interim response and decide on the next step. So let's discuss agents use Cortex Analyst and Cortex Search. Again, the structured and unstructured data itself as tools. And then along with the LLM to analyze and generate answers. After deployment, customers can track metrics, refine behavior for continuous improvements. Um, and again, at the end of this, how it's available as agents is available through REST APIs, which you can use across the board. Today, I'm going to show you how to use it on a website. But we also have examples of how to use it on Streamlit, on Slack, on Teams, on Zoom, essentially wherever your data is or your customers are to be able to communicate. This is where agents can live through the REST API itself. So talking a little bit more about the structured and unstructured data that needs to be processed. So Snowflake is the world's best platform for efficient AI and SQL powered processing. On the core processing engine, we deliver numerous innovations to reduce query time by 40% in the last couple of years. So if you want your data information quickly, especially in the chatbot experience, that is very important. No one wants to sit around waiting for their answers. Even if we, as UI developers, provide a little swirl or something to kind of keep their attention, understanding that something is happening, it still needs to be quick. So that way they can move ahead on what they're trying to accomplish. And in some data cases, we've seen where something that could take 20 minutes get reduced down to 20 seconds. So overall, a huge improvement across the board. So before we dive into a little demo that I have for you to show off the capabilities, I just want to wrap things up. So Cortex agents using Cortex Analyst, Cortex Search, LLMs, and AI observability allows customers to get meaningful insights on unified governance framework and efficient processing engine for both structured and unstructured data. We remain excited about the potential of agents, and we're just getting started here at Snowflake. Agents are moving beyond basic automation, dynamically handling multi-step actions, and reasoning. This is a significant improvement over the mostly reactive software tools available today. As LLMs continue to advance, we expect agents will collaborate, plan, execute, refine tasks, driving efficiency and overall reducing costs. We believe agents have the potential to reduce both software and labor expenses by orders of magnitude. So, with that, let's dive in. So what we have here is a chat interface for AI agents. What we are is a insurance company, and we have multitudes of forms and data and documents across the board, talking about plans, about talking about what resources we have, and also the data of what kind of claims are being opened and closed, and what state they're in. So again, going back to the structured and unstructured data itself. So let's take a look at that. So we want to know how many claims are currently open and how many are $10,000 and higher. Let's take a look. And here we are. So as we talked about, Cortex Analyst provides us a SQL statement that we can run to get the claims. That SQL statement is developed by utilizing semantic models that we have created before. And the way to visualize semantic models is essentially giving the instructions of, hey, these data that's in my database, this is what they mean. Some people may say claims, some other folks may call them like invoices. And you can provide all these synonyms across the board. So that way you could provide the instructions and the nuances of your organization to Cortex Analyst. So that way it understands what data is there. And something that we recently released was a helper, essentially, a UI experience. You can go in and build your semantic models and views, which really helps really look at the data itself, see what the table names are and things, and help you build that up. So here we are. Very simple. It gives us the SQL. We run it, and this is what we have across the board. Then one more thing I want to share is with this evolution of understanding the data itself, another big thing we want to see is visualizations. And another tool that we recently released is data to charts, which will provide that experience of like, oh, okay, cool. Let's get the data itself, see it in a table, and then, hey, let's see if we could see a visualization of it. And here we are. And the last thing I quickly want to show before closing is that unstructured data portion, the search. I'm just going to ask about rental cars. We are a insurance service itself, and we may have different documents about rental cars, like in terms of what kind of coverage we have, what kind of things that we need to do for filing claims. And as you could see here, you'll see these little numbers at the end. These are citations of all the documents that search went through to find and pull this data out, so that way we have a all-inclusive look of everything. So going back to what agents does and what makes it great is be able to have one interface across the board to see data across Cortex Analyst and Cortex Search, your structured data and unstructured data. And that's it for me. Thank you for your time. And if you have any questions, please go ahead and put it into the Q&A field. Thank you so much.
Thanks, James. Excellent presentation. Much appreciated, and great insights from our team at Snowflake. And now I'm going to welcome our next speaker to the stage. From Google Cloud, we have Holt Skinner. And let me bring Holt to the stage. Welcome, Holt, and it's all yours.
So, hi, everyone. Let me open up a little presentation and all of that kind of stuff here. So today I'm going to be talking a little bit about Gemini 2.0, 2.5, all of the latest and greatest models from Google AI. Specifically, I'm going to be showing about how to run them on Vertex AI. So this is all designed for developers who want to build scalable, enterprise-grade applications that use generative AI at the core of their applications. Things like if you're building your own agents, image recognition, document understanding, text code generation, video processing, all those kinds of things. So my name's Holt. I'm a developer advocate for Google Cloud AI. I live in Austin, Texas, but I'm currently visiting New York City right now, presenting at a different event here tomorrow, actually. So what kinds of things do? I write code for a lot of other people to use. I help software engineers use AI, create a lot of technical educational content. So I've made a lot of YouTube videos and blogs, those kinds of things to help people learn about Google's technology. And I do a lot of stuff with developer communities as well. So I'm not sure, I don't know if anyone can raise their hands and stuff in this environment, but I'm curious how many people here are actually familiar with Gemini currently. Okay, looks like there's a lot of familiarity here. So some of this stuff might be a review, but hopefully everyone in here will learn at least something new about this. Okay. So of course, Gemini, family of multimodal generative AI models that are developed by Google DeepMind. It's been out for about, the actual family of models has been out for about 2-ish years at this point. But there's been lots and lots of developments. There's new developments every day, it seems like, with Gemini. If you're curious about how all of these models work, I love this video by one of my former teammates, Dale Markowitz. Is about the whole history of the transformer model and how this was all developed, which a lot of people probably know this, but the paper Attention is All You Need, which was written by researchers from Google and the University of Toronto. It's kind of what kicked off this whole generative AI revolution. So the latest version of Gemini is 2.0 and 2.5. It comes in a few different flavors, specialized for different use cases. Kind of one of the key features of Gemini, it's kind of distinct from other models out there, is the really large context window. So you can have 1 or 2 million tokens input into it, which is really, really big overall. So 2.5 Pro can take in 2 million tokens. All the other versions of Gemini can do 1 million tokens. But this is an enormous amount of data. This is like 2 hours of video, 22 hours of audio, 60,000 lines of code, or 1.4 million words. So pretty crazy stuff. So Gemini has a lot of different features specifically to build agentic AI experiences. I really hate the word agentic. I hate that it's becoming such a big thing, but it's what everyone wants at this point. So we got to say it. I got to make money somehow. And there's also features such as built-in tool use for accessing external information and performing actions on the user's behalf. I appreciate that people are laughing at that and not throwing me out of this event. So thank you. And there's also a real-time streaming or real-time live API, to handle multimodal and bidirectional input and output. So you can send in live text, live audio, video, and receive audio or text out. So it's pretty cool. You can kind of have a live conversation with it as well. And so Gemini has been making making a big splash recently because it's been one of the top models on the LLMarina.ai leaderboard. It has almost all of so on the top, I think 10 or so models on LLMarina in terms of score, 4 of those are just different versions of Gemini 2.5. Most recent, latest and greatest just came out last week, actually. It's Gemini 2.5 Pro Preview, June 5th, and it's excellent overall. Performance has been kind of wild. So we have a few metrics published, but I won't bore you with all of those. Now, one thing that I have to talk about, because our marketing department is wonderful at naming things. So we have a lot of different products out there that use the word Gemini in there. So I want to kind of take a moment to clarify this. So the Gemini model is the generative AI model behind all the different tools out there that use it. There's the Gemini web app, which used to be called Bard. And so that's available at gemini.google.com. This is mostly for consumers, anybody else who just wants to use it. Not necessarily just developers, you can use it, but it's connected to a lot of other Google services like Gmail and Maps and Google Search and all that kind of stuff. So pretty cool stuff. There's also Gemini in Workspace or in Cloud or other things like that, which is called Duet, which used to be called Duet AI. We just use the word Gemini to describe all of it. There's also Google AI Studio and the Gemini Developer API, which is designed for. Actually, you can see the call to action link in the comments right here, ai.google.dev. That is the Gemini Developer API. It's designed for kind of experimental and maybe light production use cases. But if you need enterprise grade security and compliance, all that kind of stuff, you have to use Vertex AI, which is what I'm going to mostly show here. Let me see if I'm forgetting anything. Yeah, Vertex AI Studio, a nice little UI. You can go in and play around with the API, experiment with it. You can try it out without any kind of account or anything like that. You just go to console.cloud.google.com/vertexai/studio, and you can go in there and experiment. Already kind of mentioned this. There's a lot more to Vertex AI than just Gemini. There's Model Garden, which lets you have all sorts of different models from Google, partners open source, vector searching for embeddings, Colab Enterprise for Jupyter Notebooks, all enterprisey, fun. Okay, and then if you want to use Gemini, there is the Google GenAI SDK. There have also been a few different versions of this out there. This is the current, latest and greatest one that is designed specifically for Gemini 2.0 and later. And you can actually switch between the two different Gemini APIs very easily. You just have to switch one little flag over. So pip install Google-GenAI, not Google-generative AI. That is the old version of it, because backwards compatibility is fun. And so if you want to use the Gemini Developer API, you just put in your API key. If you want to use Vertex AI, you just put in Vertex AI equals true, put in your Google Cloud project ID and your location, and then you can use any Gemini model that you want. Okay, let me see what else here. And now what I'm going to do a little demo of is one of the notebooks that is available in the Vertex AI Cookbook, which you can go to at goo.gul/Vertex AI Cookbook. There's a whole lot of different notebooks and other examples for how to use Gemini, Imagine, VO, Lyria, all the different cool models that Google keeps coming up with. Okay, and so you can access it through that QR code. The one I'm going to show a little bit of is our intro to Gemini 2.5 Pro, and just kind of shows how straightforward it is to get through it and a few of the different features that you have with it. I'll go through this kind of quickly. You just install the SDK, do some authentication, put in project ID and location if you have that, import the libraries, create a client, which is what everything is based on. We have our model ID here, which is the latest and greatest version. You can see some of this basic text generation. And now one of the newest features of version 2, Gemini 2.5, which is kind of why it's been topping a lot of the leaderboards, is it has a lot of native reasoning built right in. And you can actually control how much reasoning or thinking that it does for each response. So for example, it can solve previously impossible tasks for AI models to solve, like how many R's are in the word strawberry. And so you can actually control how much reasoning power essentially it uses for all these different requests. So you can put in a specific thinking budget, which is the number of tokens that it uses. Which will decide, it does increase the latency of the model whenever you do that, but it allows it to be much more accurate, and it kind of just essentially reprompts itself over and over again, kind of like what you used to do with React prompting, reasoning action. It does that all on its own. And you can actually see some of the thoughts that are generated by this as well. You just have to add this little flag to include the thoughts, and you can see exactly what it does in the kind of pre-prompting that it figures out for itself. And so a few other things in here. There's a bunch of other examples in this notebook for code generation. This is all available on that QR code I just showed you. I'll share it again after I'm done going with this. So we have code generation. It's really good at doing that kind of stuff as well. You can use it for vibe coding. It can generate full applications and pretty accurately from what I've seen with it. Scroll. Multimodal reasoning with like geometry stuff, math and problem solving, including lateral thinking stuff. Let's see here. System instructions, safety filters. These are kind of standard large language model things at this point. Multimodal prompting, including text, code, documents, images, audio, video. Make sure I'm not forgetting anything here. Control generation, very useful for loading output of large language models into things like databases, so you can force the model to respond in a specific structured output. Let's see what we have here. And then another kind of unique thing for Gemini is grounding with Google search. Google, of course, is first and foremost a search company, and we have that baked right into the Gemini model. So all I have to do is import the Google search tool, and then it grounds all the responses to the results from Google search. So for example, I actually ran this a little bit earlier today. I asked it for the current temperature in my hometown of Austin, and it just does a little search query and figures out exactly what the temperature is and then answers it based on that. It doesn't just make something up. So you can actually see all the citations for that. You can see all of the queries that it did and the actual websites that it ended up pulling from. Okay, function calling, great for agents. Code execution, great for code generation to verify that it works. Okay, and I'll go ahead and show you that little QR code again so you can go in there and see that. You can also go to ai.google.dev to get a Gemini API key for the Gemini Developer API. Let's see, what else do we have here? There's also this Google Cloud Generative AI GitHub repository that I and my team maintain. It's full of tons of examples for running with Gemini, Imagine, Lyria, VO, Chirp, are different models for generative AI on Google Cloud. So I think that's all I wanted to talk about today. Yeah, we've already talked about getting started. So thank you all very much. Sorry if you couldn't hear me for some of this stuff. Main thing, go to this QR code. That'll solve all your problems. So have a great rest of your day.
Thanks, Holt. And if you guys liked what you saw or want to catch up on any of what Holt discussed, you can scan that QR code that he mentioned. There's also a call to action at the bottom to book a follow-up with Google Cloud. So thanks very much, Holt. And now I'm going to welcome our next speaker to the stage, Nohyun Myung, Senior Director of Product Management at Precisely.
Well, thanks, Brian. And hello, everybody. My name is Nohyun Myung, and I lead our spatial products here at Precisely. Today, I'm going to take some time to talk to you about our Data Graph API. And our Data Graph API is a cloud-native API which provides access to hundreds of different data products and integrated spatial intelligence capabilities. So Precisely works with over 12,000 organizations globally and 93 of the Fortune 100. But one thing that we're seeing is as we discuss and work with organizations and users adopting AI technologies, we're commonly hearing about the edges of AI. And in particular LLMs, of course, always trying to provide an answer or an inference. We understand these challenges to be presented to us as biases or hallucinations, but really it's rooted in the underlying lack of data, accuracy, quality, and precision in order to have the data integrity to make trusted decisions with that information. So one thing we obviously know with LLMs in particular is that there's never enough data, right? AI models require more and more data in order to evolve and in order to be trained and learn and to provide better data and more accurate results. However, therein lies the problem, right? Acquiring high quality data in large volumes and varieties of data is not simple for organizations. Identifying, vetting, testing, QAing the data, whether that's internal data or external data, and then understanding how to create and manage those data pipelines for AI models to use is incredibly time consuming. In fact, so much so that entire teams and departments have been created within the enterprise within the last decade, called data engineering teams, just to be able to handle these problems around building quality, trustworthy data pipelines to be used throughout the organization. In fact, just as a side story, when I used to run a data science organization at prior jobs, I would say 70 to 80% of my team's time went into data engineering tasks as opposed to data science tasks. So the third part of this is that context is king in data, right? So data assets are, of course, valuable. Again, reiterating, everybody is trying to get their hands on more data. However, many organizations don't realize that what's missing in your data assets is that you need to be able to have context between those data assets to one another. Or another way to say it is that there needs to be a way to connect or enrich dataset A to dataset B to dataset C in order to amplify the value that an organization can extract from the data. A really simple example of this is if I'm trying to open a coffee shop in, let's say, Austin, Texas, what information would I need? What data would I need to be able to do that confidently? Of course, you might have sales data, right? Where do people traditionally buy, or have I sold coffee before? And where have I sold those products or those coffees? Another piece of information could be foot traffic data, or daytime versus nighttime traffic data, weather-related data, competitor data, demographic data, new development areas, right? So as you layer on those different contextual layers of information, treating those data products as separate silos is not enough. You need to be able to interlink those data products together to make better decisions. So that's where the Data Graph API comes in, right? The Data Graph API provides access to hundreds of different data products with thousands of different attributes or features for your AI models to leverage. And the Data Graph not only allows you to leverage all of these data sets, right? They're automatically updated on monthly intervals so that you can trust that the data isn't stale, while also being able to trust that it's been vetted and assessed through our data quality checks and balances. They're also contextualized with one another, like I just mentioned. So each data set contains location or geospatial attributes. So not only does each data product have direct relationship with one another, but it can also be enriched to your own data, provided it has location context. So let's get into a demonstration of this. So here I'm showing you the Precisely API developer portal. And this is publicly available, right? You can sign up with a free trial to be able to start using our developer portal. And sorry, let me just get this screen out of my way. So just to give you an overview of our data graph playground in our dev portal. So this data graph allows you to kind of explore interactively how to query and work with the syntax of our data graph engine, which is a GraphQL based API, right? So here you can see that our structure is I'm defining a query. And in this simple example of this query, I'll just run this quickly. I am defining an address as an input, right? So there's location context here, and we are then taking that address, of course, and then providing you the locational context of that. And by querying that address, what I have access to do is query and search across all of these additional data products, right, that are trusted and vetted by Precisely. So I can query for building data, parcel data, address data, property attributes, places or POIs, even weather-related perils and risk data like flood risk or coastal risk or wildfire risks. So I can basically scan any of these data sets. And of course, these data sets have hundreds, if not thousands of different attributes available to you to be able to augment your AI models with additional context. And in this case, I queried this address in Denver, Colorado. And then by querying this address location, I'm also requesting information about the building's data set. So if I go to the buildings schema here, right, I can again scan in the data graph playground the entirety of all the attributes or features that this building's data set has, and I can define it here. And what's even more important is going back to that context is that I'm not just querying buildings. So in this case, I get the building result here in my response, but I'm also then able to nest and query places from that building. So in this case, I'm looking up an address, and that's correlating to a building, which then correlates to all the unique businesses that exist at that building, because it's, in this case, it's clearly a commercial building, right? It's a commercial building with multiple commercial storefront properties. So there's Starbucks, there's an Einstein Brothers bagel shop, and what now looks to be a Dough Deli closed business, right? So these are all definable here within the data graph. So I can get access to all of this enriched data content simply through a single API interface. And then if I want to, of course, let me find another field here. Actually, let me go to the buildings. In buildings, I might just say I want elevation, I want, and the building area, right? Building type and building area, right? So I can kind of dynamically structure my request and then the response that I get to feed my AI models. Another example of this is we can use spatial enrichment. So I'm just going to go to another tab here and just to show you this free little tool that we can use to visualize data geospatially or on a map. And let me go to the Las Vegas area. So as I zoom into Las Vegas, something that I might do is, let's use that example that I was referencing earlier, where maybe I'm interested in opening up some kind of a business. Maybe it's a coffee shop, right? And maybe I've targeted this kind of suburban area of Las Vegas. And so what I might want to do is I might want to just quickly draw a crude area around this neighborhood. Maybe I've targeted this area, this neighborhood as an interesting area that I've been exploring. Maybe I want to digitize this. And now I get to create a little boundary, a little geofence around this neighborhood and say, you know what? I want to understand a little bit more about this area. So it creates this nice little well-known text formatted geometry for me. I can copy this polygon and I can input that, which I think directly in here. And I have a query structure here that defines my input geometry. I just have an input ID in case I want to provide some kind of ID to track this request with. And I also can define the spatial function. So again, if I have questions about this, I can go all the way back to the docs, go to the query methods, identify the get by spatial, and the spatial functions will tell me all the different spatial predicates I can use to perform a spatial search or spatial enrichment against this data set. And then what I'm doing here is I'm defining the various buildings data that I want. In this case, I just want some metadata. I want a summarized level of how many unique buildings are in that area of interest that I created, how many parcels are in that area of interest. And then as I get to places or POIs, I want to know the number of unique businesses and then some more specific information or more specific attribution there. So I'll query this. And what it'll do is it'll query that area. It tells me there's 304 unique buildings, 312 unique parcels, and 40 unique places. And of course, with those places, I can go and scan through all these attributes and understand what kinds of businesses exist there. So if I'm opening a coffee shop in this area, I can see what kind of competitors might be there. I can see what kind of adjacent or complementary businesses might be there to determine whether or not it's a great location to open up my coffee shop. And if you have any other questions, please feel free to reach out, and we're happy to answer any questions either here or offline. Thank you.
Great. Thanks, Nohyun. Excellent presentation. And if you want to book a follow-up with Precisely, you can click the call to action below. And now I'll welcome to the stage our next speaker, who is Ryan Jansen, CEO and co-founder at Zenlytic.
Well, hello, everyone. Thanks for attending all the sessions today. I hope they're really informative for you. As Brian said, my name is Ryan. I'm one of the co-founders of a company called Zenlytic. And I think we're just going to jump right into some demo stuff today. I have no slides for you. So what Zenlytic does is, as you can see, we have an AI chat window here, just like everybody else. What we do differently is that we really focus on the self-serve user experience. So our goal is to enable sort of the domain experts, the decision makers, the everyday folks to be able to access their data, quickly and easily. That's something that everyone sort of likes to claim they do, but it really takes a lot of very careful thinking and explainability and trust to make that possible, for a non-data expert. Now, I think y'all can see my screen here. Let's just jump in. We'll start off with some basic questions here. Let's do some fun stuff. I'm going to use our voice for this, and I'm also completely ad-libbing this demo, by the way. So let's see what we get. Hey Zoe, can you show me our revenues? Show it to me year to date. Can you break it out by product line and compare it to the same time period last year? What Zoe will do is that, she'll sort of parse my question into something that's sort of understandable and data driven. This is connected to a Snowflake, by the way, and we'll show it. So shout out to the Snowflake representative earlier. And we're also going to show a demo that uses Gemini 2.5 Pro, which is a fantastic model, I must say. So what Zoe's doing here is she's answering the question. You see, the first thing you'll notice, by the way, is that she's not talking in SQL. She's not talking in really strong data terms. She talks in sort of measures and dimensions. Total gross revenue, product type. You can set it, it's showing up again here. What Zoe does is everything in this query is, completely defined in this sort of parameterization. If you want to be a data person, you can go down. I'll just go an extra for me. If you want to be a data person, you can go and get a SQL chat or a SQL query that was used to generate this. People basically never do this, and this is a really important part of self-serve because. First, even if you knew how to understand SQL, it's kind of terrible to grog through all this and confirm what's happening. But the vast majority of people who can benefit from data don't speak SQL. And if you say, "All right, here's your plot, and this is the SQL that generated it. Is it okay?" It's the person's gonna have no idea. They're like, "Okay, I guess it's good. Like, I don't know. You're converting time zones. That's I guess you get my time zone right." It's a scary thing for an end user, and without that sort of intermediate semantic trust layer that defines, hey, this is total gross revenue. This is sliced by product type. It's over Jan 1st to June 11th, 2025, compared to Jan 24. Without that layer, you're just going to get an email to the data team saying, "Hey, is this right?" We found that users that actually have this information presented like this can trust the data because they understand the data. So Zoe's giving me this. Looks like she gives a little summary here. That's great. Thanks for going the extra mile, Zoe. Let's just drill a little bit here. Let's say something like. Okay, that's really cool, Zoe. I'll tell you what, let's just focus on the lip products and maybe just on this year. So can you drill into that and maybe give it to me weekly? And we'll let her go to it. Now, these are the sort of questions you can ask when you're pulling basic data. Interestingly enough, this is also not the way that people usually ask questions about data. So what I'm actually going to do is I'm going to jump into something that I threw in the oven. In Martha Stewart, when she's like, well, I've already, it just turns out I already put a turkey in the oven 45 minutes ago. She takes one out. I'll jump into one other one that we don't have to let her think about things and just show you a chat that I was having earlier. And that chat went something like, let's see if I still have it. Hey, Zoe, I'll be honest, I'm a marketing manager here at Pure Organics. I'm only like 3 weeks in the job, so I don't really know how to do things here yet. My boss has called me and wants me to talk about this sort of paid marketing performance. And I need your help. I don't know what we have. Help me understand the efficiency of, various kinds of channels, campaigns. Give me a concise summary. So that's the question. This is the sort of ambiguous question you can ask now when you have a data agent doing the job for you. And she says, sure, no problem. I'll help you sound smart in your meeting. She finds the right metrics. These are the exact efficiency metrics that are in the data that would be, very useful for this question. As a marketing manager, I've not even known that we tracked, PROAS, profitable ROAS. She pulls that up. She's like, all right, here you go. That's neat. And then, it turns out, here's our summary. In the most recent complete month, we spent about 1.2 million on paid marketing. On average, every dollar spent returned 4.89 in revenue. This is our CAC. Most efficient channel was Facebook top sellers with the highest ROAS. TikTok was not doing so well. So you can see very quickly that you can go from ambiguous question and just use the power of LLMs with the power of structured data to get to those answers you need faster. And I'm going to do one other fun one here. A very special shout out to Data Science Connect because we are in a data science group. We'll do one fun data science one here. I just said, hey, give me a clustering algorithm to find our top 5 user archetypes. Look across these features, whether subscription, the channels they use, total number of orders, which products they buy. Give me a cool marketing name, and then plot each cluster on a scatter plot that shows average number of orders and AOV. Zoe goes and turns on our advanced Python functionality, starts doing data science, which is really cool. Again, only our advanced users would want to go and use data science for this, but given our audience, this is kind of our result. So first we figured out, here's our archetypes. We got the premium spenders. We got the subscription enthusiasts. We've got a huge one, the casual regulars. And, they usually buy about $500 orders. They're rarely subscribers. They usually come through Facebook. We've got all of these groups. Here's a plot of them, AOV, by number of orders as promised. This has given us, again, it took us 3 minutes to do this, but this gives us a new way of looking at our data, and it really kind of unlocks the power of data science for the rest of your team. So I think I'm kind of out of time here. So I'll stop there. If you have any questions, throw them in the chat. If you want to follow up, hit me up on LinkedIn, Ryan Jansen, DM's open, or just hit that book a demo button and we can talk with the team directly. Thanks very much.
Thanks, Ryan. Great demo. And yeah, if you want to book a follow-up with Zenlytic, press the book a demo button below. Thanks for joining us, Ryan. And now I'm going to turn things over to our next presenter, Brad Moore, Senior Sales Manager Enterprise at Fivetran. So Brad, welcome to the stage.
Hello there. And Brian, thank you for the introduction.
Absolutely.
So I'm here today to talk about, so Fivetran has been around for a while. We are partners with Snowflake, with Databricks, with BigQuery, with Microsoft. We have lots of partnerships around the world. And our goal is to make data available for AI. I'm a sales engineer at Fivetran. I've been here for 3 years and happy to present today. So we are based in California, but we have 1,200 employees. We've been around for a while. As I said, we're deep partners with Databricks, with Google, with Snowflake, with lots of other partners. So the ecosystem is strong. We've been around for a while, but on an AI journey, we feel that a lot of companies get ahead of the game. Every company in the world is looking at AI, and they're trying to figure out how to use it to affect revenue, affect cost, improving customer service churn, or improving customer churn, developing more market share, or whatever. And so the journey that they're on is multi-steps. And a lot of my customers that I talk to are kind of stuck at the beginning. They're stuck at the experimentation stage. So they're looking at tools, and I've heard a lot of good tools today, but they're kind of experimenting with tools, and they haven't really gone through the process of analyzing the outcome, right? We believe it goes the other way. We think you should start with the business outcome and then work your way down to the tools. And for any AI project, data is king. Now, this is a stat we pulled from Gartner. 75% of the organizations that state that AI-ready data remains one of their top 5 investments in areas in the next 2 to 3 years. Data is king. We know that you can pull together great AI models with data, but how do you get the data? That's where Fivetran comes in. So we centralize the AI data model necessary for either GenAI or machine learning or anything downstream in those solutions. We clean the data, we make it compliant, we keep the data fresh. So it's an incremental update. So you have a SQL Server source, you have a Salesforce source, you have any one of our 700 connectors, and we keep that fresh in the target to be prepared for an AI model. So here's another picture of what we view as this journey. Fivetran is your data foundation. There's a bunch of data in your organization, in your cloud applications, in files, in places where it's hard to get. Some of them are easier than others, but most of them are pretty hard to get. Traditional ETL projects can take 2, 3, 4 months to get a data source created. With Fivetran, you can do it in a few minutes, literally. And then once you have the data into your data platform, then you can start your data management, do your business impact values, do your prototypes, and build your AI in production. So that's kind of the journey that we feel like we're on. But in the replication process, we want to make sure that we have lots of sources. We have over 700 sources. We have 25 to 30 destinations. We actually just acquired Census. So now we have 180 or 200 destinations, including being able to write back to Salesforce or write back to Jira. But we do reliable data delivery. We like to say that our data we make data as simple and reliable as electricity. You turn on the switch, the electricity comes on. Your data replication should be the same. You authenticate, you move the data, and off we go. So in an AI managed situation, the data lake is important. And there are different strategies for managing this, but some of our customers are coming to us saying that we'd like to keep it in a data lake that is agnostic of a data warehouse. And others are okay with using a tool like BigQuery or Snowflake or Databricks as their data lake. But we offer a way to do a managed data lake service in Amazon S3, in Azure OneLake, or in Google GCP. And we can actually make the data queryable in the data lake. This is a perfect place to do GenAI. GenAI is a combination of structured and unstructured data, and a data lake is a perfect place to land that. Then you can do your data science and your data modeling in a data lake, and then move the refined data to your data warehouse. So that's a big push that we have at Fivetran, is to make the data available in a data lake. Here's a customer that we've worked with. You're all familiar with OpenAI. This is an AI conversation. ChatGPT is a great solution. Well, they use Fivetran, and they use Fivetran to bring their data in and manage their internal operations at scale. So I'm going to go into a very quick demo and show you exactly how we go through the setup of a source and destination. In this case, we're pulling data from Salesforce and we're moving it over to SQL Server. So let's go right in here. So in this is a Salesforce source. You can see that we have a record. Am I jumping ahead? No, here we go. Okay, so I'm in a destination. The first thing I'm going to do is I'm going to create a SQL Server destination. We support all the different flavors of SQL Server. In this case, it's a standalone SQL Server on-prem. I just have to give it a unique name where we're going to send the data. Get this in here the right way. And then I'll add that. And then we just have to authenticate into that SQL Server. You can do a SaaS deployment. We also offer a hybrid deployment. If you want to run Fivetran on-prem, you can, or you can run it in our SaaS platform, either way. And we have to put in the host and the port, and then we'll have to give it the name of the database, and we'll have to authenticate. Getting the user and password is the hardest part of setting up a connector. In this case, we've got it, stored, so we're just going to plug it in here, And then when we're ready, we click Save and Test, and now we have a destination set up in Fivetran. This is a SQL Server destination. As I said, we support Snowflake destinations, Databricks destinations, and a bunch of others. So now I'm testing everything. I'm getting everything set up, and now I have a SQL Server destination. So the next thing I'm going to do is come into my connectors and add a Salesforce connector. I'm already logged into Salesforce. Salesforce is an OAuth connector. So whatever you're logged into to Salesforce is the permissions that Fivetran inherits. So I'm just going to log into Salesforce here. This is our Salesforce sandbox. It's not the real Salesforce. And then we'll show you a real quick summary of the accounts that are in Salesforce here. There's actually 16 accounts if we show all of them, right? So there's there's 16 accounts. This is obviously a test Salesforce instance. So I'm going to go back over to Fivetran, and then I'm going to set up a Salesforce connector. In this case, it's a Salesforce sandbox, like I said. We're going to set up here. In this case, it's an OAuth connector, and I just click Authorize. I told you we can set up some connectors in 5 minutes. That's really what we're doing here. So we have now connected to Salesforce, and we're ready to start moving data to SQL Server. So the first thing it does is going to pull back the schema. So you're going to see the schema of what we found in Salesforce. You can pick what tables you want to bring over. You can even pick what columns you want to bring over. In this case, I'm just going to bring the account table, and then I'll click Save and Continue. And we also handle schema changes automatically. So you can just allow schema changes to happen, and we move new columns, new tables, and new everything, that all the deletes and all the schema changes that come through. So now I've started the initial sync. In the meantime, this is our connector dashboard, and you can see the status of all the replications that are going on. As I mentioned earlier, Fivetran is a system that will move the data from here and put it there and keep it fresh. And so you can see there, I'm doing a sync every 6 hours. You can change that down as low as 1 minute or 5 minutes. And then once again, you can go back into the schema and you can add more tables at any time you want. And then we also support column hashing and a few other things along the way in the schema. You also see a usage tab. We keep track of all the data that we're using, and the customers are paid on consumption. So that if they don't use it, they don't pay. So now the data has synced, and it says it'll run again in 6 hours. And so now we can actually go over to SQL Server and actually show the data that's been replicated. So I'm coming in here to this particular schema. I got to refresh the schema browser to get the new table. There's the Salesforce sandbox schema that we created. Here's the tables. There's the account. We can open up the account and show the data, and there is the 16 records that we just pulled over from Salesforce. So that's really all I was going to show. I was going to show a very quick demo, and I think my time is about up. But happy to be here, and feel free to reach out with us anytime you want, and put some questions in the Q&A if you want.
Thanks, Brad. Much appreciated. And if you guys liked what you saw, please book a follow-up call with Fivetran at the call to action below. So now I'm going to welcome our next speaker to the stage, Valentina Piñas-Vivas, who is a senior data scientist at Dataiku. Welcome, Valentina.
Hey, everyone. I'm Valentina Peña, senior data scientist at Dataiku. For those who may not know Dataiku, I have a really quick little intro for you. So Dataiku is a universal AI platform that is meant to unite, people from different kinds of backgrounds, technical and non-technical, coders and clickers, your data wherever it may be stored, your different technologies that you might be leveraging, whether that is for data storage or compute, or maybe even models if you're doing GenAI, and also governance. We're really supposed to be an end-to-end platform from, first getting started with your data, EDA, all the way through to production and monitoring. For today's purposes, though, I'm going to be a data scientist at an ice cream parlor. And we, are getting ready for summer. It's like our Super Bowl. And we buy ice cream from a bunch of different vendors, depending on what is popular, what is trending on the market. So it's really important for us to figure out what is trending, how it's priced, figure out how we're going to keep up for this coming summer. So I have a big data pipeline. And about a week and a half ago, I got a ping that let me know that a big trend was starting to disrupt my data. And I did a little bit of digging, and I found out that Ben and Jerry's put out a tweet saying that they were going to be partnering with Dataiku on AI-inspired flavors this summer, starting with LLM meringue. Many more to come. So the first thing I did was check my data pipeline. And your first question might be, how do I do that? So I have a little workspace here. Actually, let me go back a click. There we go, where you'll be able to see basically what I look at every single day to keep tabs on my data. So I've been looking at tweet texts coming in. You can see the Dataiku information, the LLM meringue being mentioned. I can also see how many different brands and flavors are being mentioned a week, the number of tweets referencing AI. I built that out real quickly when I saw the data changing, and then how many tweets are mentioning these emerging trends. I also have a word cloud that lets me know how the hashtags are doing and the data getting in. So I have some mentions of Ben and Jerry's, and you'll see some up and comers, this AI collab and LLM meringue and Dataiku down here in the corner, and also some information about general trends that I'm seeing come in. I usually expect 4, 5, 6 a day, but really over the last couple days, this has been peaking like crazy. And I also have, just as a sanity check, the top brands that are coming out most often in our data. This helps us maintain good relationships. Now, you might be asking, where does the AI come in? Why don't we check what I just showed you in terms of visualizations with a nice little AI portal that I built? And really importantly, we'll get back to this in a moment. Everything that you're seeing today is fully point and click. There is no code involved in any of these bits and pieces. So Dataiku has an answers web app that comes right out of the box that lets you, choose an LLM of your choice, chat with it, maybe even point down to your existing data. In this particular case, you'll see that I'm connecting down to a live database data set. The little thing is going to tell me that it is querying the database live, and it is telling me that the most common ice cream brand in this new trend that's coming out is Ben and Jerry's. You can even take a quick look at the source. You can see the SQL query that was run and a little bit of an overview of what that data table coming out of that SQL query looks like. Now, why don't we take a look at the data project that actually underlies this whole process? So in Dataiku, I have many things going on here, but I want to focus on our Twitter analysis section. So as I mentioned, this data pipeline is built off of incoming tweets. So in this case, you'll get the tweet text, the date that it was posted, who authored it, how many retweets it got, how many hashtags. The first thing that I wanted to do was apply Dataiku's out-of-the-box LLM recipes. And there are a couple. So just to give you a little bit of a sample, we have our recipes tab over here, and you'll see we cover a couple of really common different types of operations like classification, text summarization. We also help you handle embedding if you're trying to do a retrieval augmented pipeline. But in this case, I wanted something a little bit more custom. So I went for our prompt recipe that looks something like this. You see that I can specify a model, I can specify a prompt, I can basically choose an input from the data set that I'm connecting it to, plus a lot of other important tuning parameters. And in this case, it's essentially a name entity recognition process. I'm basically asking it to pull out a ice cream brand name or an ice cream flavor. Now, I didn't get to this prompt in one shot. I used Dataiku's prompt studios, which are essentially like a nice little sandbox where you can test out your LLM prompts, figure out what works, what doesn't, test out different models, all in the same space, and also compare them. So in this case, I have one pass where I chose GPT-4o. I'm pulling in my tweets data set, and I'm basically saying I want to be able to pull column tweet text, which I'm using the handle tweet for in my prompt. I tested it out with some test cases. I could have added examples if I wanted to that would have been appended to my query. And I can get, a quick little overview of my prompts and, most importantly, a cost estimation right over here. I also tried it with a different model, 4.1 Mini. How do I decide which one I want to run with? I can select both of them and choose to compare both of these outputs on these test cases that I've pulled out. So in this case, we really want to be able to balance out the cost aspect, which we get an estimate of, with also accuracy. So having a view of this helps us figure out which is the model to go with. You can add 3, 4, as many as you want to test. And once you've picked one, you can essentially export that as a recipe and just save it right back to where it was originally. So this really helps you with figuring out how to use and how to build the best prompt for your task. What's really nice is I can then interweave that with other regular cleaning steps. So in this case, I have a couple of pre-processing steps where I'm either replacing values or I'm removing columns. All of this is really helpful. And then I have one more prompt recipe over here where I'm basically asking it to distinguish between tweets that are related to a new up and coming trend or people who are just expressing an opinion. So let's take a look at the output of this to see how it did. If I pop into this data set right here, I have a filter already set only for those where emerging trend flag is true. And we'll see again that this is pulling out that Ben & Jerry's and Dataiku collab really well. It's flagging all of those LLM and meringue tweets, which we love to see. So really quickly, before I show you some more cool AI functionality, I did want to flag, as we saw, there was that alert mechanism. I do have a whole system down here that basically relies on different data set health metrics and checks. So if it detects more than that 6 expected trends, 5 expected trends, it'll send me an alert. And I have that automation here under Dataiku scenarios called new trend alert. You'll see that I have a couple steps where it's building data sets and running checks. And then every single day that this happens, if it finds something, it will send me an alert on Slack. And that's what that screenshot that you saw does. Awesome. So we've used LLMs to help us prepare our data, get some insights. We saw how to build that web app. And again, as I mentioned, fully point and click. In Dataiku, it's as simple as creating a new web app, and you'll see this answers option. That is essentially what gives you this nice little interface that we saw previously, where you can ask any questions, you can add some sample questions. All of that is handled through our fully point and click implementation page. But once we have that, how are we going to tell this story back to our execs? Dataiku recently released some really exciting new functionality called Dataiku Stories. And what it basically helps you do is create a full slide deck presentation without having to leave Dataiku itself. And what's really powerful about it is that it allows you to keep your data live. So in this case, you'll see I have 3 data sets from that project already connected. Whenever they change in the underlying project, they will change here as well and always be up to date. No need to have any explicit refreshes. And what's really nice is that you can view them, you can do some pre-filtering, you can do some cross-filtering, and this unlocks you for building visualizations, slides in a more traditional way, really however you like. So let's take a look at some of the options I have here. And let me get rid of this so that we can build it afresh. So one option you could do is, again, point and click, build traditional visualizations. So let's say that I want to take a look at the count of retweets for each of my flavors. With just drag and drop, I can basically overlay those 2 variables and it'll recommend a bar chart already. And we can check that, that LLM and meringue really is getting a ton of retweets. This is a great sign that our exec should be investing in this new flavor because it's probably going to be very popular this summer. We can also build these visualizations in another way. I can also go into a blank slide and I can grab maybe a note that my manager may have left me, telling me they want to see a histogram of tweets by brand. Stories also includes Story AI, where with plain English, you can describe a visualization that you want and have it essentially instantiated in your slides. So this one always takes a little bit of a sec while it thinks, and you'll see that you have that little Story AI magic happening in the middle. And here you go. We have our bar chart based off of plain English that's pulling from those connected data sets that we have here on the side. And again, we can really flag that that Ben and Jerry's flavor is the most popular so far, at least in terms of tweets and who's talking about it, and we should be paying attention. So you have more slides. You can add more at the click of a button. Really, the story that you choose to tell is entirely up to you, whether you want to do it point and click, use AI. And one more fun little AI functionality that Dataiku also includes is the ability to add different AI images. So you'll see I have here my AI-inspired ice cream that I built for today's presentation. And I hope that we get to convince everyone that AI ice cream is going to make our summer even cooler this year.
Excellent. Thanks, Valentina. And if you like that AI ice cream and want to book a follow-up demo with Dataiku, do so at the call to action below. Thank you, Valentina.
Thank you all.
Now we did on Greg's presentation earlier with Zerv, we had little issues with the screen share. I just want to sorry to put Greg on the spot if he's not ready, but Greg, I just wanted to pop you back up if there was anything else that you wanted to show that you weren't able to show the first time around.
Can do here. So I've just uploaded a file, that same CSV as before, and I'll just put in the same prompt here. Explore the CSV file and do EDA on the data and build a probability of default model. We'll just keep it real simple. So like I was saying, Zerv is the operating system for data in AI. And so it gives you access to the entire process. So it's a full-featured development environment where you can use Python, R, SQL. You can connect to Snowflake, Databricks, all your data sources. Anything that you could do in a VS Code or anything like that, you can do in Zerv. But we're going to so if I wanted to, I could drag in a Python block and I could execute code and do all that stuff from scratch, but people don't really do that anymore these days with the advent of agents. So what our agent will do here is the first thing once you ask it to do something is it'll come up with a plan like we saw before. And so in this case, it's going to load and inspect the data and summarize the key statistics about the data set, identify the target variable. And so it's going to take a guess at what the target is. It's going to do some visualizations, and then it'll train a logistic regression model, it looks like. So what I could have done here, it's asking me for some stuff. So it asked me for what the target was. I didn't end up telling it. It'll take a guess. And it's asking for other specific features and stuff like that. But I didn't give it any of that. It just wanted to check with us before it started. So I meant to type do it, but I typed do. That was good enough. So it's doing its thing now. And so you'll notice a couple of things. It's kind of giving you some insight into what it's doing right now. But our agent can actually create blocks. It can blocks of code. It can run blocks. It can execute code. It can debug errors. Here's the first block that it's created. It's loading the data set, and it's doing some previews and some analysis of what the data looks like. And it'll keep on going after that. So now it's doing some descriptive statistics and things like that, and it's executed that code. And now it's doing target analysis. So it's looking to see if it can figure out what the target is. And so now it's created an error. So this will be interesting. I'm actually glad this happened. So it's created some error, and it's tried to use a string variable as a float, tried to convert it. And so it's going to go back and try and actually fix this error live. So it'll be interesting to see how it goes about that. But it's just going to kind of go about its business. Now, while it's trying to solve that problem, let me just kind of walk through some of the other different areas in the app so that you can get a sense for how things work. So everything in Zerv operates in layers. And so this is just one development layer. But keep in mind, this is a collaborative environment. So I could have lots of people signed in. And previously I had Rebecca, my colleague, in moving her mouse and moving around. It's a very Google Docs-like experience. So you can all edit code, all run code, and do everything in a very collaborative way without a lot of the problems that you run into with other collaborative environments. Oh, that's interesting. Okay, so it did fix its error, and it's looking at correlation with loan status. So it's properly identified the target variable, and it is showing us which variables seem to be important on a univariate basis. So that's interesting. And it's done some EDA plots and stuff like that. So we could scroll through these EDA plots that it's built. Looks like some correlation matrices and stuff like that. But like I was saying, it's a super collaborative environment. So if you're familiar with tools like, say, a Google Colab or something like that, Colab is in the title, but it's actually not very useful from a collaborative perspective, because it locks cells, and if multiple people are trying to do things all at the same time, then you end up with problems. But in this case, there's nothing stopping anyone from going in there and writing code and executing it. And the reason is that each block here operates its own kernel. So they're all independent. And when I click go, what it does is that it'll spin up serverless compute and execute the code, starting with the inputs from upstream. And then it'll take all of the variable space from running that block, and it'll serialize it and cache it and store it on disk, so that it's preserved and accessible downstream to other blocks, and also accessible from external. So if I train a random forest, then it's essentially hosted, and I can query that thing from anywhere. I can build my own APIs in another layer. I can schedule jobs to run on a recurring basis. I can sync with like a GitHub or a Bitbucket and create merges and pull requests and handle code versioning and that sort of thing. I can work with all of the dependencies. So if I need to add packages, it's very easy to just pop in, maybe I want to try an XGBoost model. I can update the packages and then click build, and it'll rebuild the Docker container that's supporting the canvas. And so you can see what's happened here is we're all done. We've gone ahead and we've got this model trained. And so that's interesting. But it didn't actually draw any curves or anything, any accuracy metrics. So can we visualize the model accuracy? And so it'll go in, and the nice thing about the agent is that it's got full canvas context. So it knows about all the files, it knows about all the blocks, all the layers, all the requirements. It knows all of that stuff, so that it can kind of understand the entire project without having to be told what to do. So here's its plan again. I'm going to say do it, and we'll see it draw some ROC curves and some other types of visualizations and stuff here shortly. So that is the agent, and I just want to highlight that it's available. It's available on our free tier, and so anybody can sign up. Just go to zurv.ai and get in there and give it a spin. So there you go. Second time. Did the screen share work?
It did. All smooth sailing there. So thank you, Greg, for doing that again. And thank you to everyone in our audience for tuning in today. Appreciate it, Greg. And if you wanted to book a follow-up call with Zurv, be sure to click the call to action right below, and it's in the chat now as well. So I want to say thank you again to all of our partners for making this a great demo day. Thank you again for all of those of you in the audience for joining us. If you missed any of this demo day or want to rewatch, you can refresh this page, and it will be at this same URL just a few minutes after this webinar ends. We'll also be sending out the YouTube video to our audience tomorrow. I want to say thank you again to all of our sponsors, our headlining sponsors, Snowflake, as well as our sponsors, Zurv, Google Cloud, Precisely, Zenlytic, Fivetran, and Dataiku. We'll see you all again next time. Have a good one.